This video is to help you understand page 356, numbers 29, 30, 32, and 34. In numbers 29 and 30, you are given the graph of two polynomial functions which are listed below each function. In addition, when you look at the graph, you can see where the graph crosses the x-axis. And that would be -2 and +3 in number 29. And then in 30, it crosses between 0 and -1, between 0 and +1, and then +2. So we have a quartic, degree 4, and to find all the factors of the polynomial, we need to at least reach the quadratic level, which means we need to start by doing synthetic division with one of our zeros to get the cubic level, and then another of our zeros and reach the quadratic level. So I'm going to select here, and it really doesn't matter. They're both integers. So I'll go with -2. I could have selected +3. I'll do +3 second. And you could reverse those. So if I do -2 first, of course I drop down my leading coefficient of 1, found from the polynomial function below. Then -2 times 1 is -2. The sum is -4. -2 times -4 is +8. That sum is 7. That gives me -14, which is -12. And that gives me +24. And I should fully expect that I get a remainder of 0, since those values are zeros where the graph crosses the x-axis and should go in evenly. So now, rather than writing that all out in polynomial function form as 1x cubed minus 4x squared plus 7x minus 12, I'm just going to do a second synthetic division, and I'm going to use my other zero now of +3. And remember, when I do this, I need to bring the 1 below the line. 3 times 1 is 3. When I add -1, that would multiply to give me -3, which is +4. And when I multiply 12, and the sum is 0. And again, I fully expected 3 to go in evenly to the resulting polynomial, because both zeros have to go in, but I did 2 consecutive synthetic divisions, so I went from a quartic to a cubic, and then from a cubic to a quadratic. So when it says find all the factors, the polynomial function f of x is going to have to factor into x plus 2, x minus 3, and then this row here tells me that I have 1x squared minus x plus 4, and I don't think that's going to factor because there aren't two numbers that have a product of 4 and a sum of -1, or sum of 1. All right, so in number 30, I have lots of choices, but we're starting with a cubic here when I look at my function. So I only need to do one synthetic division to reach the quadratic level. So what makes the most sense, since I don't know the exact values of the zeros that are between -1 and 0 and 0 and +1, is to use the integer value of +2. So 2 times 20 is 40. When I add -7, that gives me -14. When I add -6, the product negative 12, the remainder is 0. Again, I fully expected that. So now what I know here is that f of x in factored form is going to be x minus 2, and then 20x squared minus 7x minus 6. This time, I think it's quite possible that this may factor. I'll go with 5x and 4x. And let's see. I need to get 7, so I would go with 3 and 2. And that would be 15x. And that would be 8x. And 15 and 8 have a difference. Remember, I'm looking for a difference of the outside and inside products to be 7, and that's what I get with 15x and 8x. My signs are going to be different. I want negative 15x plus 8x, and that's negative 7x, and now I have all the factors. So that's what you do in 29 to 30. You use the graphs to identify zeros for which you can do synthetic division to find the resulting polynomial 1 degree less. And then once you reach the quadratic level, you factor what you're left with if it's factorable. Moving down to 32 and 33. These two are also related. These are great SAT problems. It gives you a division problem, and it says find the values of k so that each remainder is 3. Of course, division with a remainder of 3 can be found synthetically. In number 32, I'd want to put a 1 in the half box and do synthetic division. So 1 times 1 is 1. When I add that 0, 1 times 0 is 0. And so that just means k plus 0 equals 3. So k has to be 3. So that's the missing value. In the next one, I'm going to put in the opposite of k. So negative k times 1 is negative k. When I add, I'm just going to write 5 minus k. So then in the next step, I would have negative 5k plus k squared, if you want, because I'm multiplying negative k times the quantity 5 minus k, and that product is negative 5k plus k squared. And so what I know is 7 minus 5k plus k squared, I'm just adding the column, has to equal 3. So it looks like we have a quadratic, k squared minus 5k plus 7 equals 3. Hopefully you recognize you need to get everything on one side equal to 0, and I'm going to leave the rest up to you. It should be factorable. You should find 2 values of k, and that is how you do numbers 32 and 34. What you have to understand at the honors level is you've got to challenge yourself to think how you put together all these pieces that we learn. No one can tell you when you take the SAT what you have to do in these problems, but you've got to search your knowledge base and say, what do I know about division? What do I know about remainders? And we are learning about synthetic division, so you need to put that all together to help you solve the problem. All right, I hope that helps you with those problems. Get those finished up on your homework and watch the next video, which was recorded in a previous year, but to help you with day 1 of section 6.1.